In this video, we will going to take up one more problem. The problem number 37. For the beam shown in the figure, so the figure shows the overhanging beam. Determine the magnitude of the load P. So this is the magnitude of the load P acting at the point C such that the reactions at supports A and B are equal. Suppose A and B should be equal. Draw the SF and BMDs indicating the values at the salient points and locate the point of Contra flexure. So since he has given the reactions of the support should be equal, so what should be the load? So by taking the support reaction, he is given RAV is equal to RBV. So RAV plus RBV will be equal to, that is 45 into 4 plus P. So that will be equal to RAV plus RBV is equal to 180 plus P. So 2 RBV is equal to 180 plus P. Therefore, RBV will be equal to 90 plus P by 2. So taking the moments about the point E. So RBV, what is that? RBV into 6 will be equal to 45 into 4 by 2 plus P into 7 plus 30 will be equal to, so RBV we know that it should be 90 plus P by 2. So substitute that value into 6 equals 7 into P plus 390. Therefore 540 plus 3 into P will be equal to 7P plus 390. Therefore 150 is equal to 4P. So that will be P will be equal to 37.5 kilonewton. Once you get the value of P, then RAV is equal to RBV, which is equal to 90 plus 37.5 by 2, because the value of 90, here he has given RBV is equal to 90 plus P by 2, you substitute the value of P as 37.5. So therefore, you will going to get 108.75 kilonewton on either side of RAV and RBV. Now we will going to find out the shear force diagram. SF at A will be equal to plus 108.75 kilonewton. SF at point D will be equal to 108.75 minus 45 into 4, which will be equal to minus 71.25 kilonewton. Between D and B, it remains constant. SF at B will be equal to minus 71.25 plus 108.75, which will be equal to plus 37.5 kilonewton. SF at C will also be equal to plus 37.5 kilonewton. So this is how you will be getting the shear force diagram. So SF at A is 108.75 kilonewton, and as SF between A and D, which will be equal to minus, because due to UDL, SF varies from plus 108.75 kilonewton, drops down to minus 71.25 kilonewton because of the uniformly distributed load. Between D and B, it remains constant at 71.25 kilonewton. At the point B, because due to the point load, SF increases from minus 71.25 kilonewton to plus 37.5 kilonewton. Between B and C, it remains constant at 37.5 kilonewton. SF at the point C will also be equal to 37.5 kilonewton. So that is what we have given the explanation here, plus 108.75 kilonewton to 71.25 kilonewton according to the equation of straight line, and it remains constant between 71.25 kilonewton between D and B. Then between B and C, SF is constant plus 37.5 kilonewton. That is, between B and C, it remains constant at plus 37.5 kilonewton. So now we will going to find out the bending moment diagram. So the bending moment diagram, BM at A will be equal to 0, BM at D will be equal to plus 108.75 into 4 minus 45 into 4 into 4 by 2 minus plus 30, which will be equal to plus 105 kilonewton meter. So BM at B will be equal to plus 108.75 into 6 minus 45 into 4 by 2 plus 2, 4 into 4 by 2 plus 2 plus 30, which will be equal to minus 37.5 kilonewton meter. BM at the point C will be equal to 108.75 into 7 minus 45 into 4 by 2 plus 3 plus 30 plus 108.75 into 1, which will be equal to 0. If you see the plotting, BM at the point A is 0, BM at the point D will be equal to 105 kilonewton meter. But we cannot join between these two. That is because SF is changing its sign from positive to negative value at this point E. So therefore, at that point, you will going to get the maximum bending moment. Therefore, we cannot join between these two now at this juncture. So we need to just take the points. So that means it will going to be BM at the D 105 kilonewton meter. Then BM at B will be equal to minus 37.5 kilonewton meter. So you join between 105 kilonewton meter to 37.5 by a straight line. Similarly, between B and C, it will going to be from minus 37.5 to 0. So you can join between these two. Now we want to find out the bending moment varies from 0 to 75 kilonewton meter according to the equation of parabola, and then changes suddenly to 105 kilonewton meter due to couple. So, due to couple, then we have maximum bending moment. So the maximum bending moment will going to be at where will occur where the SF changes its sign. SF changes its sign between changes its sign at E and B. So where let the distance of point E be x meters from A. So then therefore SF at E will be equal to 0. That will be equal to plus 108.75 minus 45 into Y. So Y will be equal to 2.417 meters from A. And bending moment at the point E will be equal to now 108.75 into Y minus 45 into 108.75 into, you can take it as Y itself or X, both are one the same. Here we have taken that it as X. So 108.75 into X in 108.75 into X minus 45 into X square, X into X by X into X by 2. So that is 108.75 into the value of he has considered as Y. So we will going to take it that as Y. It will be 2.417 minus 45 into 2.417 into 2.417 by 2. So on simplification, you will going to get it as 131.406 kilonewton meter. So you join between 0 to 131.406 kilonewton by means of a parabolic curve. From that, it join further drops down to 75 kilonewton meter because due to the UDL ending at the point D. So because due to the couple, it suddenly rises to 105 kilonewton meter. Then maximum bending moment or the positive bending moment is at the point E, which will be equal to 131.406 kilonewton meter. Now maximum negative bending moment is at the point B, which will be equal to minus 37.5 kilonewton meter. Now we will going to get the point of contra flexure. It is the point where the bending moment changing its sign from positive to negative. So the point of contra flexure is at the point F, which is at a distance of Y meters from C. So therefore, BM at F will be equal to 0, which will be equal to minus 37.5 into Y minus or plus 108.75 into Y minus 1. So minus 37.5 into Y plus 108.75 into Y will be minus 108.75, which will be equal to 0. That means I am opening this bracket 108.75 into Y minus 108.75 minus 1 minus 37.5 will be equal to 0. Therefore, 71.25 into Y will be equal to 108.75. Therefore, Y is equal to 1.5263 meters from C. So therefore, the distance where the point of contra flexure will going to happen is at 1.5263 meters from the point C. The point of contra flexure is 1.5263 meters from C. So this is how you will be able to find out the point of contra flexure, the maximum bending moment, and also the bending moment diagram and the shear force diagram for this particular problem. Thank you.